Let us look at spread spectrum technique. Spread spectrum technique is a very important signal processing in CDMA. In fact, it forms the backbone for CDMA communication. Let us look at some of the main topics. What is spread spectrum? Why spread spectrum? What is the coding gain? What is direct sequence spread spectrum? What is frequency hopping spread spectrum? All these things we will see in the next few slides. What is spread spectrum? Let's look at the animation. Spread spectrum is a transmission method in which the original signal utilizes a spreading signal whose bandwidth is many times the original signal, and the spread signal is transmitted over the air. For example, in CDMA, user data is at 19.2 kilobits per second, and this is spread by a spreading sequence which is at 1.2288 megabits per second. Please note the user data is in kilobits per second and the spreading sequence is in megabits per second. And this spread signal is transmitted over the air. One example can be, imagine that you are in a party. Lots of youngsters are there. Music, dance, lot of speech activity, everything is going around. And you are in one corner of the room and your friend wants to convey some message to you, but he happens to be at the other corner of the room. In between there is a lot of noise. If he needs to communicate with you, probably he wants to say, I am going home. If he says it just once, you will not be able to pick up because there is a lot of noise in between. But if he keeps on saying, I am going home 3 or 4 times, then you get a pretty good idea that what he is trying to convey is that he wants to go home. What he has done effectively is, instead of saying it just once, he has repeated it again and again and again, which means he has spread the spectrum in terms of time. Supposing I want to send just 2 bits, 1, 0. If I send them only once and the interference level is pretty high, at the receiver, it's likely that either 1 bit or both the bits will be received in error. Therefore, if I need to spread it, instead of sending one just once, I can send it 100 times. A single 1 can be replaced by 100 ones. Similarly, the single 0 can be replaced by 100 zeros. Of course, the transmission rate goes up by 100 times. At the receiver, out of these 100 ones, maybe 60 have come out alright and 40 have become errors. The receiver will still be able to make a majority decision based on the 60 ones received and say what was originally transmitted was 1. Therefore, this has got inherent protection against a very high error rate or very high interference situation in the transmission. So this is called spread spectrum technique. Having understood the spread spectrum using an example, let's look at the real situation. Input speech in CDMA is digitized and compressed. To this, error correction and other control bits are added, and the data is made available at 19.2 kilobits per second. A long sequence, a pseudo-random sequence bit stream is generated at 1.2288 megabits per second, and both these streams are multiplied or exclusive OR in the time domain. Thus, input signal at 19.2 kilobits has spread its spectrum to 1.2288 megabits per second by this process. So this is spread spectrum which is actually happening in CDMA. Let's animate this diagram a little further. Now you will see the combined signal of many such users being sent over the air. That is, there are many such signals from several users simultaneously present in the air interface, and all of them have the same frequency. Let's animate a little further. What happens at the receiver? At the receiver, the signal is first despread using appropriate codes and the original signal is recovered back. How? We'll see this shortly. Therefore, to summarize, Spread spectrum uses a pseudo-random code at the transmitter that is independent of data sequences. The same code is used at the receiver to despread the received signal to recover the original data sequence. We will see more about these things in the next few slides. Let us ask some questions on this spread spectrum. Why spread spectrum? What is the concept of spread spectrum? How does the spectrum spread really? The input signal at a lower data rate and a PN sequence at a far higher bit rate are multiplied, typically exclusive OR, in the time domain. Okay. But how does the spectrum spread really? This is a simple Fourier transform property. You may have to go back and brush up your fundamentals. You may recall that multiplication in time domain is convolution in frequency domain. Hence, by multiplying a narrowband input signal and a wideband code sequence, the multiplied signal will have the spectrum which is very similar to the wideband PN code sequence. How does spread spectrum give secure communication? The spread signal gets the characteristics of the PN code sequence. Only that particular receiver which has got the proper sequence will be able to decode this. For all other receivers, this signal will appear like a plain white noise. Therefore, the security is provided by this spread spectrum communications, in particular the PN sequence that is employed in that. What is coding gain or process gain? The process gain of a system indicates the improvement in the signal noise ratio exhibited by a spread spectrum system. The process gain is equal to the ratio of the wideband spread spectrum bandwidth used to the original data bit rate. In CDMA, it is typically 1.2288 megabits per second divided by 19.2 kilobits per second. This converted as a dB ratio will give you the process gain in dB. Now comes the important question. Why spread spectrum? There could be at least three main advantages. 1. Spread spectrum signals are highly resistant to narrowband interference. This is a major advantage of spread spectrum. It enables thousands of CDMA mobile subscribers to communicate simultaneously using the same frequency and the same bandwidth at the same time. The figure identifies many types of such interferences such as background noise, external interference, interference from other cells in the network, interference from fellow users around within the same cell, etc. At the receiver, the signal received is buried deep in all these interferences and is virtually indistinguishable, as you can see. The process of despreading the signal at the receiver spreads out interfering signals, causing them to diminish into the background, and the required signal pops out literally from the debris. It's almost like a magic. The third advantage is that spread spectrum signals have high security over the air and therefore difficult to intercept. A hacker cannot decipher the signal since he will not know the pseudo-random sequence. Spread spectrum transmissions can share a given frequency band with many types of users with minimum interference, all of them using the same frequency spectrum. The spread spectrum signals add minimal noise to the desired communication. As a result, bandwidth can be utilized very efficiently.